We use index numbers to portray how a series of data, often calculated or composed every year, changes, and to make it easy to see the relative changes. The most famous example is the retail price index, which is a measure of how prices go up and which gives us the idea of inflation. Let's look at this data of the price of an item over 4 successive years. It starts at 60p, ends up at 91p. But how big an increase is that really? It's not too obvious just by looking at those numbers what the percentage increases are. So what we do is take one number as the base year and then calculate the others relative to that, always in percentages. So let's start by taking 2001 as the base year, and then we will divide every other year by that number to find the relative proportions. So we start with that base year, we put equals the number. Now for this one we're going to divide it by itself, but we will need to keep that denominator fixed, so we need to put a dollar sign either side. That means that when we move the formula, the denominator will always be 60, and we want percentages, so we times by 100. That gives us 100. So our base year is 100. Now we click and drag the formula, go to the bottom right hand corner, left click and drag, and we see the index numbers for successive years. So relative to 2001, the price in 2002 had gone up by 10%. By 2003 it had gone up by 26%, and so on. And so that's the base year of 2001 with giving the following years relative to that base year. We might want to do a bit different base year. We might want to take 2003 as the base year. So if we do that, we can start here. Again, we have an equal sign for a formula. We divide our actual price by our base year price, but then we must keep that fixed when we do our divisions, when we drag our formula. So we need dollar. That means we'll always be dividing by 76 even when we move the formula along. And again we want to multiply by 100. And if we click and drag that now, I've got my base year now is 100 in year 2003, and the other years now are relative to that. And notice that the percentage changes are slightly different. When we had 2001 as 100, there's a 26 2/3% increase to 2003. When you look at it the other way around, from 2003 back to 2001, there's only a 21.1% decrease. The numbers change because we're using different denominators. So you need to choose the base year carefully, the one which you think is the best one, that's the most reliable, and then everything else works from there. So these are index numbers of single quantities, single amounts, single items of sale.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.